Good morning. Thank you for your interest in my e-poster. This presentation is part of my PhD thesis that I'm currently doing at Newcastle University, focusing on earthquake cycle in Taiwan from Earth observations. Here is the content of this e-poster presenting my work on the co- and post-seismic deformation of the Chi-Chi earthquake using Earth observations. In the central western part of the island occurred the major and most destructive inland earthquake of the 20th century, being the Chi-Chi event. This earthquake was due to the reactivation of the Chelumpu Fault, a thrust fault on a north-south striking fault plane dipping to the east. During the 3 months following the event, thousands of aftershocks occurred, including 6 with a magnitude greater than 6.5, starting at the north and migrating downward and southward of the main event, most of them happening at shallow depths. In this study, several types of geodetic observation have been selected: GPS, IRSA images, leveling, and spot optical images. The main goal of this study, in addition to the modeling of the fault and the slip distribution analysis, is to take advantage of the variety of datasets available nowadays and to set up a methodology to precisely use them jointly. O'Keefe's dislocation theory has been generally used to study and invert seismic fault displacement. Joint inversion of the datasets and a precise estimation of relative weighting is done. Different coverage, number of points, and uncertainties are the main problems requiring a relative weighting. The final distribution is continuous on all segments of the fault and consistent with previous model from the literature. The slip distribution shows that the main deformation happened in the north part of the fault, where the fault is curving toward the east with a slip reaching 12.6 meters, and most of the moment was released at depths shallower than 4 km. These results showed the essential need of joint inversion to determine relative weights precisely when using several datasets and constraints, which are presenting various characteristics, to properly balance the contribution of each of them. The postseismic deformation is a transient part of the interseismic phase, lasting from days to decades after the rupture. Its study is useful to constrain rheological properties of rocks. It is a complex system composed of several physical processes linked to the redistribution of stress in the lithosphere and asthenosphere. In this study, a forward model based on Berger's rheology is used to estimate the afterslip distribution and the lower crustal strain over the 20 years following the earthquake. Most of the afterslip is happening on décollement from the middle of to the southern part of the segment. Small deformation is happening on the main segment in shallow depths. Afterslip is absent in the region of maximum co-seismic slip. Here are presented the main conclusion of my study. Please, any questions and suggestions are welcome on the chat or by email. Enjoy the rest of the conference.